Hello, Matt G4IYT here. Today we're looking at the full license mock examination, number 1, version 1.6. We've reached question 45, which reads, a quarter wave vertical antenna installed without an RF earth and connected to a transmitter is likely to cause A. Excessive noise on receive, resulting in an inability to receive weaker signals. B. RF currents in the mains earth and power leads. C. Difficulty in getting a low SWR on the feeder to the antenna. Or D. Frequency instability due to RF getting into other sections of the transmitter circuitry. So let's think about the most basic kind of antenna, which will be the dipole, and that will have effectively two legs, and then one of those legs is the inner of our coax, and the other leg is the outside of the coax, and so we're providing a radiating element, and we're providing an RF earth. And that's not really any different from, let's say, an off-center fed dipole, where you might you feed it actually from, well, it's off-center fed, so it's not quite fed in the middle, right? And in turn, that's not all that different from your end-fed half-wave. So you have your matching box, and you have your long element going off around the garden, and then your feeder coming in the bottom here. But you've also got your counterpoise as well. So this is still looks quite a bit like a dipole. Yet this leg is much larger, much longer than the counterpoise leg. We've got this impedance transformation box here, maybe doing a 49:1 or maybe a 9:1 impedance transformation at the feed point, to make it possible for you to match it to your transmitter, but it's still an antenna that's split into two parts, and it's also no different. It works for every antenna, so it's no different for your quarter wave vertical. You just happen to have your radiating element pointing up into the air, and then you have your RF earth, happens to be some radials on the ground. So what would happen, and I mean I've already drawn them in, so we'll have to imagine they're not there, but what would happen if I didn't have radials here and I connected my transmitter with a feeder like that? Well, we've not provided any RF earth for this antenna, but it needs one in order to work. So it will find one. And in this case, and in most cases, if there is no suitable earth system built in as part of the antenna, the next best thing is going to be the outside of the coax leading back to the transmitter. It's connected to the earth side of the coax, that checks that, and it might even be might even be a reasonable length. You may get unlucky and may find that your feeder is exactly a quarter wave on a particular band, and so it may make the outside of your coax may make an ideal radial for your antenna system, and that's guaranteed to happen if you don't provide an RF earth as part of your antenna system. And so you end up with, because the alternating nature of radio signals going one way, then it's going the other, you end up with RF currents on the ground side of your antenna. If you've got RF currents on the ground side of your antenna, and the ground side of your antenna is the outside of your coax leading back into your transceiver, then what you're going to end up seeing is RF currents on the outside of that coax. The outside of that coax is going to be connected to an SO239 connector, which is going to be on the back of your transceiver. That's going to be connected to the chassis of the transceiver. The chassis of the transceiver is likely to be connected either to mains earth, or it's going to be connected to the ground side of your shack power supply, which in turn may be connected to mains earth, depending on the design of the power supply. Either way, you're going to end up with RF currents either getting into the mains earth or even getting into your power leads, because there will be a direct connection, and there will be a path for it to some kind of ground or some kind of earth through the outside of the coax. So why is it this answer and not any of the others? Well, it's not A, because this A is talking about receive, and we're told this is about a transmitter, so it's about the transmitter. We only want to be thinking about transmit, so we can rule that one out quite easily. C, difficulty in getting a low SWR on the feeder to the antenna. Well, that is actually a symptom of option B, RF currents getting into the mains earth and power leads. If you're struggling to get a low SWR onto the feeder to the antenna when you don't have these radials, it's because it's using the outside of the coax as part of the antenna, and of course that's going to affect your tuning and therefore your SWR. However, that is a symptom of of option B. That happens because of option B. It's not necessarily the reason that it happens. And then option D, frequency instability due to RF getting into other sections of the transmitter circuitry. Well, I don't know about frequency instability so much. We can scrub that out, right? But RF getting into other sections of the transmitter circuitry, maybe you get reports telling you that you've got RF on your audio. As RF getting back into the shack, maybe it's every time you key up the lights dim or something like that, or it turns your computer monitor off, or your mouse stops working. And again, that's because you're getting RF coming back into the shack, because you've got RF currents getting back down the outside of the coax and into your mains earth and power lead. So again, option D is a symptom of option B. So let's skip down to the answers and see if we've got that right. And we can see, of course, for question 45, the answer is option B. And the lesson here is we always want to make sure we've got a decent ground system for our antennas, because if we don't provide one, it's going to find one anyway, and you're going to be spending ages trying to figure out why every time you key up, your keyboard turns off. Thank you very much. I'll catch you for the next one.